properties, okay? And then questions 31 through 42 are problem solving.
So we can have a calculator, right?
Yes, you can have a calculator for everything except, you cannot do I've already told you there's a standard deviation problem. I wanna see your work on the standard deviation. We'll do it on the board.
We can use it for the square root part.
Calculator.
Yeah.
I just mean you can't go in there and go standard deviation with these numbers.
Oh, no.
I don't even
That's what I mean. No, yes, you're free to use a calculator for
Okay,
any
cool.
type of square root or anything like that. And then there is there's one thing that's on the test where you don't need you gotta label some, okay? But the others are math problems. So we'll probably have a Scantron to answer the first 30, and then you'll stick that and you'll have to work the rest of the problems, all right?
Yes, sir.
Okay, I've looked at this test, I looked it over Jason, and I both did. Guys, study those definitions that are in D2L. Now, I know I gave some handouts a couple of days that already had definitions, but there are a lot of questions on your test that you'll be able to get right if you know the definitions to certain things, like molarity. Like, somebody tell me what molarity, anybody know remember the definition?
The concentration.
Over liters.
Good, the number of moles of solute per liter of solution, okay? That's a definition, but you've got lots of other definitions, shifts, trends, all that stuff. Be able to recognize them. They're probably gonna be in a multiple choice format, okay? So just be able to recognize what a definition is, okay, on that. Let's talk about clot tubes versus anticoagulant tubes. If I take a clot tube and spin it down, what's the supernatant on the top called?
Serum.
Okay. If I take a blue top or a green top or a pretty color, okay, that's got anticoagulants, if I take it and spin it down, now what do I have on the top?
Plasma.
Okay, everybody feel comfortable with that? Remember that? I think that was at the very end of chapter 1, I think it talked about, which we briefly mentioned that. Pipettes. We spent a lot of time talking about pipettes. Somebody tell me about, what's the most accurate pipette there is?
Volumetric pipette.
Okay, everybody agree with that? Okay. Somebody give me a feature of what can you use to identify a volumetric
It's got a
pipette?
bullet.
It's to deliver.
Good, both of you are right. Most pipettes, if they have a TD stamped on it, that means to deliver. If they were to have a TC, which there's not many more that do, but if they were to have a TC, that means to contain. Like a volumetric flask may say TC. It contains a certain amount, right? Like if I looked on this, and I'm probably gonna eat my words on this, no, I'm right, it does. This has a TC on it. So this will contain exactly 1 liter, but if I take it and pour it upside down, it won't necessarily deliver 1 liter. All right, but it's the perfect apparatus for to contain 1 liter. But TD stands for to deliver. So the biggest thing I would tell you, volumetric, they're the most accurate, and they have a bubble in them, okay? Or they have an area that's larger than the rest of it for a volumetric pipette. Somebody tell me about colligative properties. What am I talking about when I say a colligative property, Darren?
Boiling point, freezing point. Osmosis.
Okay, osmotic pressure and vapor pressure, okay? It's basically, what are physical characteristics that will happen to a solution if it's concentrated, okay? If water has a lot of sodium and chloride molecules in it, okay, it's gotta get a lot colder to freeze that,
Right.
okay? And if you were to try to boil it, you gotta make it a lot hotter to boil it, okay? So just understand, basically know the definition for colligative properties. Let's talk about safety, okay? Let's say our lab is broke, we have no money, we don't even have enough money to buy disinfectants to actually wipe down the countertops. What's the cheapest thing we could ever use if we just didn't have anything?
Bleach.
Okay, what's the percent bleach?
10%.
Okay, right. So if we really got in a tight in there, we could go to the Dollar Tree and buy some thing of bleach, right, and dilute it up, and we could use that to clean our countertops with. That's a real cheap way for doing that. Now they make all different types of stuff, and we've even got some. We've got some high dollar spray in there that you guys use. But bleach, 10% bleach can also be utilized to disinfect things. Let's talk about solutes and solvents. Somebody try to tell me the difference, like what is a solvent versus what is a solute? And what is a solution?
Solute is the Kool-Aid.
Bingo. Solute is the Kool-Aid. That's what's in the packet, right?
The solvent is the water. And
Yes.
the solution is
The
the
whole
whole
thing.
thing.
Yes, bingo, bingo. Now all you gotta do is replace that with some high pollutant word of chemicals, okay? Yes, yeah, that's right.
Solvent and the mixture together is the solution.
Yes, that's right, that's right. Like if you're measuring glucose, glucose is your solute. Usually your solvent is at least equal to or in greater volume than your solute. If you think about it, right? A solvent is, we add water, we add buffer, that's the solvent, okay? Like we add water to the Kool-Aid, okay? But when you put the whole thing together and you have the glucose and the water and everything together, now we have a solution made, okay? So just understand those three basic differences between solute, solvents, and solutions. There'll be a question on your test about something like that. Safety information for chemicals. Safety information for chemicals. When we think back to that safety lecture that we did, name me something that will help us out.
The safety data sheet.
Everybody agree with that? Safety data sheet. What's the old name for it?
Material safety.
Okay. Hopefully I fixed the test where it doesn't say MSDS, it says SDS. There's another thing that I don't know if you remember about that we looked at that can tell you a lot about a chemical too.
The triangle, the blue, the yellow, the green.
Triangle? Anybody remember what that thing's called?
NFPS?
Yes, National Fire Protection Agency. Good. Okay, National Fire Protection Agency. It looks something like this, except yours probably won't be forward. Okay? So if I ask you two things that can tell you a lot about chemicals, the safety data sheets, right, that contains all that information. But if you just wanted to glance at a chemical and see how flammable it is, boom, the National Fire Protection Agency symbol would be on it, right? Or you could see if it's a health hazard, what the reactivity of it is, okay? Remember the numbers and the coding system? And guys, a lot of this stuff I'm telling you will probably be on the urinalysis test too, okay? Because remember, we had safety in both of these.
Right.
Jason and I figure if you hear it 4 times, you're gonna learn it, okay?
Yes, sir.
All right. Fires. Let's talk about fires for just a second. The fire extinguisher that we use, okay? You're the lab director. You don't wanna have to have a water fire extinguisher, a fire extinguisher for electrical fires, a fire extinguisher for liquid fires. So what kind of fire extinguisher can we get?
A dry ABC.
Good, I'm hearing all good things. It's called an ABC fire extinguisher, right? And it utilizes a substance called dry chemical. What's dry chemical? I don't care. It's just called dry chemical. It's in the fire extinguisher we have in there. So if I asked you what's the mnemonic, in case you go into shock because there's a fire, what's the mnemonic you would use?
Pass.
Squeeze.
Okay? And a fire in general, what's the mnemonic? Race. Good.
Rescue alarm. Contain and evacuate.
Okay, the chapter that talked about descriptive statistics. There's quite a few questions that come from that chapter. To me, they're easy things, okay? First of all, when we did that chapter, and I don't even know what chapter it was, but when we talked about descriptive statistics, we talked about words that can be used to describe the center of data, words that can be used to describe the spread of data, and words that can be used to describe the shape of data. You remember us talking about that? Okay, so if I said a bell-shaped Gaussian distribution, what would that be describing? Shape. If I use the word average, what would that be describing? Center. The center, right? Remember one of the things is describing the center of data. Mean, median, and mode. That's the 3 M's that describe center. Okay, there was a couple of things that I drew out on the board for you that describes how to measure the spread of data. Like how far are the points away from the mean? Do you guys remember? Bingo, that's the number one thing, standard deviation, but there was another word that we talked about too.
Variance?
Yeah, that goes into it, but don't forget range.
Range.
Range describes the spread of data as well, okay? And if I ask you a question, what's the overall term used to describe the shape, the center, and the spread of data, it would be called, starts with a D,
Distribution.
descriptive statistics. Okay, that's the overall word used to describe all of that. What percentage of values will fall within one standard deviation?
68%.
Good, I didn't think y'all get that, 68%. Okay, well, we gotta know the other two. Remember I told you guys to memorize this.
90.
Two standard deviation, 95 and 99 on three standard deviation. I told you don't worry about the decimal point, okay? Just remember the three key words there. If I say quality assurance, I'm talking about that is a guide to measure the overall process of a patient from the very minute they come to the hospital, okay? Like quality assurance is, if we compare that to laboratory values, you're talking about the pre-analytical aspect, the analytical, and the post-analytical. Quality assurance is everything combined, okay? But now, for you guys that are gonna be eventually MLTs, a lot of times we deal with quality control. Quality control measures just the analytical process, the testing, right? We have quality control that we do in the laboratory. That's just the testing. Quality control will not help you with anything about whether that patient was fasting, okay? Or how we reported out the results. Quality control, basically you're working on an instrument and you're running magnesium results all day long. You run these little quality control vials to make sure that the magnesium results that you're turning out for all your patients are correct. Quality control measures the analytical process. Quality assurance measures everything. In other words, that's a way where we can, I guess if you wanted to, you could call all your patients that came in that day and do a survey and said, did you truly fast before you came to the hospital today? Okay, that encompasses quality assurance. So know the difference between quality assurance and quality control. Know the difference between a standard and a control. Now, you got those definitions. A standard is a substance that has a known exact value. A control is a substance that has a range, okay? Now that range is still gonna be, pretty close, but you're gonna have a low, a medium, and a high, but it has to fall within a range. Like if I was to look at this bottle for the QC, or for the reagent strips I was showing you today, I guarantee I can look on this bottle and it will tell me, for example, it says the level 1 control, it says should fall between 25 and 55 milligrams per deciliter. That's a control, all right? If it was a standard, it would say, we have a vial of solution and it contains 67 milligrams per deciliter of glucose. It has an exact value. We talked about analytical processes. There was a couple of key terms that I told you guys to make sure you know what a probe is. Make sure you understand what a delta check is. Okay, anybody have questions about that? A delta check, what a probe does, how it functions. Remember there were three basic approaches to automation. I told you guys we were only going to talk about discrete analysis. That's what all the instruments use now, but remember we also talked about, there was one called centrifugal analysis, remember that? Make sure that you know the three basic approaches to automation, but other than ask you the name of them, I won't go in depth about anything except discrete analysis. That's where an individual machine can run one sample at a time for multiple tests like that. That should be pretty fresh on your memory, that wasn't that long ago we talked about that.
Just making sure, like, for that, like, you either want one test, like, multiple chemicals, or
Yep.
multiple tests, or, multiple tests.
Yes, yeah, that's discrete. There were discrete analysis, continuous flow, and centrifugal analysis. But the one that I wanted to hone in on again was discrete analysis. Okay, there's a section, that's pretty much all I'm covering on your multiple choice, okay? Oh, I shouldn't even told you that. Remember I told you there's gonna be matching on the test. The matching that you'll have, as far as it's not really called matching, but you're gonna have to be able to tell me, there's about, I think, 4 points worth of questions where it deals with 1 liter equals how many milliliters? 1 deciliter equals how many liters? The same question you had in intro to MLT, except the numbers are changed. You've got to be able to do conversions. It's only metric to metric conversions. Don't waste your time studying pounds and ounces and all that. It's only gonna be things like liters to microliters, microliters to milliliters, and things like that you will have to be able to either add zeros or move your decimal.
Is that fill in the blank or is it multiple?
Fill in the blank.
Okay.
So that'll be something that you'll have to actually do. The molarity problems, okay? Guys, be able to do those molarity problems. Remember I wrote a formula on the board and I told you about how to solve for molarity. We covered certain questions in the book and I covered certain ones for a reason, and I told you, like, put an asterisk by the questions that we do. They will not be the same exact question. Like, don't memorize, don't tell yourself, like, oh, if he says this one problem, he'll be using 44, because I will change the numbers, but the problem will be the same.
Right.
Okay, so if you can do that problem, just be able to throw in different numbers, okay? You might be asked, calculate the molarity, or you might be asked, how many grams will it take, okay, to make a 2 molar solution using a 250 milliliter flask. So you have to be able to do it both ways, right? Now, generally in years past, I'm just telling you, for this particular test, usually students do pretty well on the multiple choice on the first 30. But where students usually, not their downfall, but what makes that test go from a 95 to a 75 is the problems. Okay, so I'm just telling you, hopefully that won't happen this year and everybody will do good on both parts of it, but there'll be problems. I'll do that, okay? We just gotta work with it, but I'm sure there's been days we've been loud too. They get too loud, I'll go over there. Or we can go in that. Making up dilutions, okay? There's gonna be questions about dilutions where I'm gonna ask you, make a 1 to 10 dilution, and here's what you have to work with, okay? You have a 1 ml pipette, you have a 100 microliter pipette. I want you to make a 1 to 10 dilution, tell me how you do it, okay? So you gotta be able to answer that question. Now, that's probably not the question, but you're going to be given certain situations where you have to use the pipette that's specified in the problem, okay? So don't just think, okay, I know how to make a 1 to 10. 1 mil plus 9 mils is a 1 to 10. It's not gonna be that easy. You're gonna have to think about it, okay? So there are dilution problems on the test as well. Remember, out of all of the modes of measurement, I spent a lot of times talking about spectrophotometry, okay? I would know the components of a spectrophotometer. If I was to ask you anything about atomic absorption, from what I told you, you guys play the instructor, what do you think I'm gonna ask you? What kind of lamp is used for atomic absorption, since you said that, Patricia?
Tungsten?
Tungsten oxide.
That's the atomic.
Oh, yeah, something like that.
Hollow cathode or?
Hollow cathode lamp.
Okay.
Okay, again, atomic absorption, I don't expect you to be a wizard at atomic absorption, but there are some major things that separate it from different modes of analysis. One of it is your sample is actually aspirated into a flame, okay? When you're measuring atomic absorption, you're measuring the absorption that atoms are gonna have, not molecules. So what I told you to know about atomic absorption, I think I covered 3 things. First of all, they normally do it to measure trace metals, like copper and all that. That hollow cathode lamp, although I don't know a lot about it either, I do know that hollow cathode lamp has to be the same substance that you're measuring. So if you're measuring copper, you have to have a copper hollow cathode lamp. If you're measuring aluminum, your hollow cathode lamp has to actually be made of aluminum, right? Again, your sample is a flame on that, hollow cathode lamp, and trace metals. That's the main things that I need you to know about atomic absorption. Spectrophotometer, your light source, again, is a tungsten lamp usually. Don't forget what a monochromator is, okay? It separates individual wavelengths of light. You got a sample cell, right? And then you're gonna have a photo detector, and then you're either gonna have a readout or a galvanometer. Okay, all those different modes of measurements, there's quite a few questions on that. We talked about things like osmometry, we talked about nephelometry, we talked about chemiluminescence, atomic absorption, spectrophotometry. All of those, you don't have to know everything about it, but know the basic principles, okay? Now again, Jason and I both agree, we've got to, even though we want you to learn this field up and down, we do, in a roundabout way, try to teach to the test that you take, the ASCP register. I don't think there's nothing wrong with that, okay? So instead of you learning every single little thing about these different modes of measurements, I'm gonna say a couple of key words here, and I want you just to tell me which measurement you think I'm talking about, okay? Light scatter, something that causes the light to scatter. Nephelometry, okay? Now I know the definition is gonna say, okay, the light will scatter at a 90-degree angle, okay? But you at least, when you take your registry, because you're gonna have so much information by then, if you ever hear the word light scatter, more than likely they're talking about nephelometry, okay? What if I said light produced as a result of a chemical reaction? Great, chemiluminescence, okay? What if I put, even though we haven't done the lab yet, what if I put the migration of particles due to an electrical current applied to it?
Electrophoresis.
Electrophoresis. And there's different types of electrophoresis. And again, we will be having a lab on that. There's hemoglobin electrophoresis. What we're gonna do is called protein electrophoresis. But it all has to do with the migration of particles due to their size, the molecular weight, and the charge that you're applying. They separate out, okay? That's their physical characteristics. Again, you guys have a sheet, I think Patricia's already on it, but you have a sheet that talks about all those different modes of measurement. Be aware of those and be able to at least answer multiple choice questions based on those different. Right, I don't really think there's a lot on this test where spelling would matter. Okay, for the most part.
Just a second, okay, it's
Well, I mean, chemiluminescence is a long
You
word,
guys know what
so.
ISE stands for?
Oh, ion selective electrode?
Ion selective electrodes. We talked about those. Talking about usually those measure electrolytes, and it has to do with a reference electrode based on the potential gap between the electrolyte you're trying to measure and the reference electrode. What about a technique where you're trying to measure the number of dissolved substances in a solution? Anybody remember that one?
Osmo.
Good. Osmo, like a urine osmo. You're trying to detect how many sodium or chloride molecules are in a urine specimen. All right, I feel like I covered a lot of good stuff. Do you guys have any questions for me on it? Again, I'm not trying to get on a soapbox, but you're gonna start off good on this test. Give yourself give yourself some room for the tests that are coming up, okay? We did skip a few chapters as far as up to this point, but there are quite a few chapters involved. Do not just, read. You guys have got to, yeah, Tim.
Oh, you go ahead and finish what you're saying.
No, I just mean like, there's just certain things, guys, that I'm dependent on you to do on your own the same way I do before I give a lecture. Like, there's nothing wrong with you getting on the computer and typing in thin layer chromatography YouTube video, and you will see them do what I tried to show you on the board. I didn't think I did a good job explaining that to you from the expressions on your faces. So if there was anything about like thin layer chromatography or anything, you can watch video after video after video on that stuff to where you'll see them actually doing this little experiment where they're separating out compounds based on the solvent that they're using, okay? So do that. You have got to develop, and I didn't do it when I was a student, I'm guilty, but you got to approach this field as something that you're interested in, okay? You can't approach it as something like, oh, I got another class I gotta go to. You're probably gonna be doing laboratory stuff for a long time if you finish this program, unless you decide to not go into this field. So studying becomes a lot easier if you will develop an interest in it. If you will kind of go at it from that angle and not just, I got a micro test, I got a chemistry test, I got this, and it's in 3 days. But a lot of people learn easier if you can develop an interest in it. It may not be you sitting in this classroom hearing me talk all the time. I would get tired of that. So figure out what works for you best. And that might be YouTube videos, that might be getting with other students and studying in a study group. For some of you, that might be the wrong thing to do. You may be better studying on your own. I've seen students every year before a test or whatever, they go out in that hallway because, the students are in here studying and cramming and stuff like that, but that doesn't help them. It gets them kind of flustered or confused. Everybody's different on their study habits. I'll help you in any way I can. I will, you got my cell phone number. If you're struggling with these molarity problems or the pipetting or the dilutions, we don't really have tutors for the MLT program. Like Jason and myself, we're your tutors. I'm sorry, but you're stuck with us, okay? But anytime we'll try to work with you one-on-one, if you can see a window where we can sit down with you, or if there's a couple of you that want to get with us one-on-one, you will not have an unfair advantage, okay? I've had students kind of call me out on that before, saying, well, you're studying with them on the side or whatever. Everybody in here has that benefit. If they want to get with me one-on-one, or if Haley and Kennedy both want to talk about dilutions or whatever, I'm not going to tell you what's on the test, but I'll go over dilutions where I hope you have a better understanding of it. So.
Am I still good to take my test tomorrow?
You gotta take your test tomorrow. Okay, you got this remind. I've got it ready to go. All I have is 3 hours. And somebody else is gonna take.
Friday.
You're taking yours Friday, you're taking yours tomorrow. Okay, got that.
So my question, you said that there was about 30 multiple choice, so there was a few fill in the blank and then the math problems. What about like essay, like writing sentences or something like that?
There are no essays on this test that I'm aware of other than calculation of problems.
Okay.
Depends on whether you call that essay or not. Like if I ask you a question that says calculate the mean and the 2 standard deviation with the following 10 numbers. Well, that's kind of an essay question, but it's not writing out sentences or anything.
So it'd be a good idea to study percent solutions, molarity, unknown concentration. There's another one. Standard deviation. Is that
Mean, be able to calculate a mean, be able to do a standard deviation, be able to do dilution problems, be able to calculate an unknown concentration. Remember Beer's law where I wrote that formula on the board? Absorbance of the unknown divided by the absorbance of the standard times the concentration of the standard. That's the calculation for an unknown concentration. Yes, if I know me, there's a question like that on the exam. Okay. Molarity problems. But now, again, don't just go home and study just the questions that say, what's the molarity? Because some molarity problems, they give you the molarity, but they're wanting to know how many grams are actually in the bottle, all right? So be able to do it both ways, and I did it both ways on the board for you guys, and I showed you that formula. You are welcome, if you feel comfortable doing those problems a different way, where you're using the rule out method or something like that, perfectly fine, just show your work, but you have to get the right answer, okay? I normally do not give partial credit, it's an all or nothing thing, but I do wanna see your work regardless. Even if you get the right answer, I don't want just the right answer wrote down, okay? Make sure that you show your work. All right, so what do we got up here? I know y'all, okay, so we got the chemistry test is Monday, micro test is Tuesday, and the urinalysis test will be that Friday.
Tomorrow's quiz and micro will come in.
Okay. All right, so that looks good on the board. Yeah, because this Friday we will cover a chapter, we'll have a review, and we'll do our first lab this Friday in urinalysis as well.
Alright, is that, are we done?
Okay, how about let's start lab at,